Hello, and welcome to another episode of Low Spec Labs. Before we get started, I would like to stop and say thank you. Thank you to everyone who has commented. Thank you to everyone who has liked these videos. Thank you to everyone who has already subscribed. If you are new to the channel and you would like to continue receiving some IT and automotive content, please go ahead and subscribe. Otherwise, let's get started. We finished chapter 19, now it's time to start chapter 20, which is configuring SSH. We've kind of already gone over SSH, but let's go through a quick summary of what SSH is and how it works. This chapter is going to go through hardening SSH on Linux servers. I already have a video that kind of discusses what SSH is and how it works. I believe that video is all the way back in chapter 5, connecting to Red Hat Linux systems. So go ahead and give my YouTube channel or my TikTok channel a quick visit. Scroll back to about January or February, and you'll have a nice 30-minute video that goes in depth into what SSH is and some common things you can use it for. This video is about hardening your SSH session. What happens when you place your SSH server on the internet? It's going to get attacked, of course. I've placed servers on the internet, and within about 10 to 15 minutes, people were trying to log into my SSH sessions. This is regardless of whether or not you change the port. Just because you change the port number of a service doesn't mean people can't detect what service you're running behind it. So, how do you actually protect your SSH server? Well, there's a few options you can run through to protect your SSH server. Let's walk through some of them. So, how do you actually secure an SSH server? Let's walk through some options. The first one, your first option, we've already talked about before. You could try changing the default SSH port. This is known as security through obscurity, and honestly, it's only going to defend you from the lowest of the low-level hackers, the script kiddies who are too misinformed or lazy to scan all your ports and actually look at the protocols that are responding behind those ports. Anyone with even a little bit of knowledge or education is gonna blow right past this. Your second option to secure your SSH port makes a little bit more sense. This is to simply go ahead and disable password login. So what that means is, in order to log in, you have to use SSH keys. This is honestly one of the best methods to secure your server, because then people are going to need your pub keys and your priv keys. This is honestly the best way to secure your server, because then you need 2 keys for you to get into the system. The third option you could use to secure SSH is to configure SSH so only certain users can log in via SSH. So you might have a service account, and then you configure things so only that service account can log in. This is also another rather sane method to protect your SSH server. And the fourth option, which is now enabled by default on RHCL9 systems, is to disable root login. So oftentimes when hackers are trying to SSH into your system, they'll use the root account, because that tends to exist on most Linux systems, and then they'll try to use something like a dictionary attack and brute force your password in order to get in. So if this chapter is about configuring your SSH server, you should probably know what file you're going to have to edit in order to config SSHD. That file is located at etc ssh sshd_config. To your left, or on the bottom of this screen, you're going to see an example SSH config. Let's go ahead and walk through this to see what the settings are, and let's actually try to see what things we have to change to apply those 4 security changes we need to help lock down our server a bit more. In order to edit our SSHD config, we're going to need a text editor. My preferred one is Nano. You can use VI or Vim. All 3 are going to be included in your default install of RHCL. If you use Vim or Nano, you should get a color-coded text output like this. Now, let's go ahead and see how we would go about making changes to our SSHD config. If you're paying attention, you'll notice that most of this config file has comments next to it, these pound signs. What this does is disable the configuration. So if we wanted to enable a configuration, we would simply remove the pound sign. And disabling a setting is as simple as putting the comment back in. So the first step we can use to change our SSHD config and make SSH more secure is to simply change the port number. So right here, if we were to change this port number to something like 222, we would be increasing our port number and making this server moderately more secure. After we've changed the port number, we hit Control X and save. And then we have to do a systemctl reload SSHD. And then it's going to ask for our password. And there we go. And now SSHD should be running on port 222. The second thing you can do to help lock down your server is to prohibit password logins on the root account. So again, in order to do that, what we would do is scroll down and see if we can find the right setting. So you'll notice here we have permit root login, prohibit password, and that one is commented out. So right now, the root user is unable to log in whatsoever using SSH. If we were to uncomment right here, so by simply uncommenting this line, root login is now enabled, but it'll only allow the root user to log in if they're using public-private key pairs. After that, we save. After saving, we go back to our command line, and then we just do a quick systemctl restart. So we can do sudo systemctl restart SSHD. And there we go. That's all we need to change that config and to lock down the root user account a bit more. Another thing you can do is change your config so that all accounts that want to access SSH has to use pub key authentication. How do you do that? Well, we have to edit our SSHD file again. So we go ahead and we log in. And what we do is uncomment this section right here. Pub key authentication, yes. And what that basically does is force all accounts to have to use the public key private key pair in order for them to log in. And finally, you can limit SSH to only specific users. How do you do that? Well, since we're already in our SSHD config, all we have to do is scroll down and find the allow user section. So let's see here. So after scrolling through the file, I can't find that section, but thankfully, in order for us to apply a setting, all we have to do is use some text. So it's as simple as doing something like allow users. Notice how I have capital A and capital U. Capitals do matter in this config file. And then I'm going to put the two users I want to access. And so from now on, only those two users, LSL and SV, can now access this server via SSH. And then of course, I want to do save. Then I want to restart SSHD. Then I want to check the status of SSHD to make sure it's running. And there we go. So those are the 4 simple ways to lock down your SSH server. Another way you can lock down your SSH server is to use SE Linux. What is SE Linux? Let's find out together. What is SE Linux? Well, do you enjoy suffering? Do you enjoy administering your server like you're fighting a Dark Souls boss? Then you're gonna like SE Linux. SE Linux is an application or utility baked into modern versions of Red Hat that allows you to apply security policies to applications, network ports, services, and files. It lets you define who and what programs have access to those resources. This video would be twice as long and would contain lots of unnecessary information if I included all the details about what SE Linux can and is used for. So we're not going to bother with that. We're just going to focus on locking down your SSH server with SE Linux. Let's try it out. Earlier in this video, we changed our SSH port to port 222. That's it right here. If we were running SE Linux, this would not be enough to have SSH connections successfully connect to our server. We'd have to change the port in the SSHD config file, and then we'd have to change the port on SE Linux. So the port has been changed. We restart the service. And as you see, when we try to restart the service, we get an error message. That's because SE Linux is managing security for this. So let's go ahead and let's change our SE Linux port. So we know what our port number is. How do we change this port number so that we now have access to port 222? Well, first we have to add port 222 to this SE Linux label. To do that, we do sudo se manage port -a -t SSH port T. So the -a adds a port, and then we're referencing the tag, which is SSH port T. Then we define the port we want it pointed to, so we do TCP, and then we can actually put the port number there. And there we go. Now, when we run SE Linux again, you'll notice we have 2 ports defined to that label now. Now, when we go in and we do a sudo systemctl restart sshd, it runs successfully because we've added that additional port to SE Linux. So we have a table to the left or to the bottom. And what this table does is basically give us a summary of various config options we can set in SSHD. This wouldn't be a very good advanced SSH config video if I didn't go over some of these. These are the bare minimum options you should have a knowledge of. You're not going to need all of them, but you will need most of them. This table is a representation of the various options you'd see in your SSH config, like so. So all of these options from this table, if you just write them into the config file, we'll set them. Let's go over them and what they do. We've already gone over port earlier in this video. That sets the SSH port. Permit root login actually allows the root user to log into the system. Max auth tries sets the maximum number of times a user can try to log in. Max sessions sets the maximum number of sessions a user can use. Allow users limits SSH to only certain users. Password authentication allows password login. TCP keep alive cleans up old SSH connections. Client alive interval is actually a setting set on the server, and it's basically the server deciding how long in seconds it should wait once a disconnection appears before it cleans up that connection. Client alive count max sets the number of client alive packets to be sent from the server to the client. Use DNS is whether or not the SSH server or the SSH client will use DNS to connect to one another. Server alive interval is a setting you set on the client side, and what that does, it tells the client how long you should wait before you consider the SSH server disconnected. And server alive count max sets the number of packets the SSH client will send to the SSH server to determine whether or not it's alive or dead. What are SSH public key private key pairs? Let's find out. SSH public key private keys are a cryptographic way to connect to SSH servers without passwords. So basically, both your server and your client generates 2 keys, a public key and a private key. The server and client then exchange their public keys. The public key is used to encrypt messages back and forth between each device. In order for those messages to be decrypted, we need the private keys. The private keys are called private keys because they are kept local to your server or client and they are not shared. So let's walk through the actual key exchange process. I'm using a different diagram to make things a little bit simpler for you to understand. So we have step 1, where the SSH client generates SSH keys and exchanges its public key in green with the SSH server. The SSH server adds that public key to its database and generates an encrypted message that it then sends back to the client. The client then decrypts that SSH message using its own private key and confirms the identity of the SSH server. The client then responds back to the SSH server with another encrypted message confirming the identity of itself to the server. After that, the encrypted communication tunnels between server and client starts. So that is a lot of high-level theory. Let's walk through a practical example. Thankfully, I've already gone over this through chapter 5, so we're going to refer to past Stephen, and he's going to take care of you guys and explain with an example how this works.
All right, so how to connect using public keys and SSH. Let's get started. First, we log into our SSH client. This is host 10.0.21.3.8. So first things first, we switch to our root account. Then we do SSH key gen. And then it's going to ask where we want to save. We're going to save it to ID_RSA. It's going to ask for a passphrase. We'll leave it empty. It's going to ask for a passphrase again. And there we go. We just made our first SSH public key. After that, we then copy that public key to the remote server. To do that, we do SSH copy ID root, and then we point it to our server 10.0.21.3.9. Then it asks if we want to continue. We hit yes. It doesn't ask for this password for that server, so we enter our password. Okay, so we ran into an issue. In order to log in as root, you have to enable root login on the server. So I went ahead and fixed that off screen. Let's try that SSH copy ID again. Then we're going to ask for our password, and there we go. Our key is now copied over, and we can verify that by doing an SSH root at 10.0.21.3.9, and you see when we do an IP address grep inet, our server IP has changed, and we're able to log into that server without even using a password because it now has our public key. That is officially it for Chapter 5, Connecting to Linux Systems. We covered a lot of topics today. We covered SCP, SFTP, rsync, SSH, so many different topics. Please go ahead and hit like, comment, and subscribe if you like the content. Chapter 6 should be coming out within the next couple of days. It's about users and groups, so we shall see. I feel pretty comfortable with that topic, but you feel comfortable and then you read the book and you realize you know nothing at all. So we shall see.